Alright, hello everybody. So now I'm finding the divergence of this particular uh, term. I have to say that it's equal to 0 for when our vector is different than our prime vector. So how do we do this? Well, first of all, I want to set, just for simplicity of writing, r minus r prime equal to 0. Sorry, actually, I got confused. Equals to uh, another vector, just a distant vector. So we would have divergence of this vector minus the same vector, absolute value, cubed. Now, one thing that you can remember is that vector unit is equals to our vector divided by the absolute value of the same vector. So we can rewrite this part here as divergence of our r unit vector divided by our r squared vector. So when we do this, well, we have to remember that when we use spherical coordinates, the divergence will be very particular. It will actually be 1 over r squared, and then the partial derivative in terms of r, sorry, it will be r, okay, of our r squared times 1 over r vector, which is r squared, so I keep running this r vectors. And as you can see, these two cancel each other out, so we will get 1 over r squared times the partial derivative in terms of r of 1, which is equal to 0. So as you can see, we get it that is equals to 0. And that is the solution to our problem. Okay, I guess I'm using a hexagon. Alright, thank you. And that was pretty easy. I mean, it is easy if you remember what you're doing. Of course, this is valid if um, our r vector is different than our r prime vector. It's pretty easy if you remember it, but of course, the book actually walks you through it pretty well too.